Hi, hello, welcome back to our channel. Today we are going to discuss about what is the day one program of our crash course. It is belongs to both Eamcet, NEET as usual for main students. So simply I am explaining the formulas and related problems you should practice, and previous year problems also I am discussing day one, day two like that program. So anyway, first we are going to discuss about units and measurements chapter. If there is no units and measurements in our daily life, we can't say the difference between different people, different persons, different physical quantities and all this. Suppose we are calling two members, how can you say the difference? One is the thin, one is the fat, one is the tall, another one is the short. At the same time I am calling 10 members. How can you say that? So with the help of the physical quantities like mass, length, you can say the difference between different persons, and it is easy to say the distinguish between different things. So like that, when we are going to the shop, suppose we can't ask give the tomato like that. They are asking immediately how much quantity. So there also we require how much we require. That is also from the units and measurements. Like that, today what is the temperature? So temperature, force, momentum, acceleration, speedometers, frictions, all belongs to physical quantities. We should measure that one. So each and every physical quantity is called that units, and because of with the help of this only we can do anything and we can do any experiment, and it is playing an important role. So then, first of all, what is physical quantity? Any measurable quantity is called the physical quantity. Like mass we can able to measure, you can say that is the physical quantity. Like temperature we can able to measure, yes, that is also physical quantity. Like force, momentum, all belongs to physical quantities. So any measurable quantity is called the physical quantity. But how can we represent the physical quantity? Look here, it is the always we can represent this physical quantity equals to numerical value into unit, and you can say Nu equals to constant also, and we should write it N is inversely proportional to unit. From this what you are understanding? More unit, less number, less unit, more number. And one of the example, look here, 1 kg equals to 1000 grams. See here, N1 equals to 1, and this unit is the kg. U1 equals to kg. Here N2 equals to 1000 and U2 equals to grams. See here, N1 is less but unit is more. Here N2 is more but unit is less. That's why what do you say? N is inversely proportional to U. So you can write it N1 U1 equals to N2 U2. This is the N1 U1 equals to N2 U2. So any physical quantity like force, Newton and dynes are there. Then like energy also in CGS system, ergs are there, and in case system that is the joules. Like that, there are different physical quantities, and whatever the physical quantity we can represent this one. Then there are two types of physical quantities. One is the fundamental physical quantity, another one is the derived physical quantities. What are the fundamental physical quantities? These are independent. These are does not depends on the other physical quantities. What are the example? Mass, length, time, temperature, current, all belongs to fundamental physical quantities. Then what are the derived physical quantities? These are not depending. These are depending on the other physical quantities. Suppose force is there. If we want to calculate that force, we know about the mass, that acceleration, then time, and these are derived from the fundamental physical quantities. That's why these are the derived physical quantities. But for measuring the physical quantities, there are three systems. First one is the CGS system, MKS system, FPS system, and now everything is globalization and we have to follow that. That is called the SI system. So there are four systems to measure the physical quantities. Look here, first one is the MKS. MKS. Here we are taking physical quantities: length, mass, time. Then CGS system. Then FPS system. Look here, M belongs to, we are measuring the length in meter. Then K belongs to kilograms, mass is measured in kilograms. time is in seconds. Like that, this is the centimeter, grams, and same seconds. Then FPS is the foot, pounds, and this is the seconds. So this is the system, and these three systems previous they followed this system. There are three systems, but I am saying now there are four systems to measure the physical quantities, and one more is there, that is called the SI system. One more is there, that is called the SI system. Look here, according to SI system, how many fundamental physical quantities there and how many supplementary physical quantities are there. Look here, first one is the length. Length unit is the meters and dimensional formula is L. Then second one is the mass, unit is kg, dimensional formula is M. First letter usually they are taking. Third one is the time, unit is the seconds, this is the T. Then fourth one is the temperature or thermodynamic temperature, also we can say that. This is measured in Kelvin, dimensional formula is the K. Then fifth one is the current, unit is the ampere. In dimensional formulas we can take A or I, any letter you can take it. Then sixth one is the quantity of substance, this is unit is the mole and dimensional formula is MOL. Then seventh one is the luminous intensity. It is the candela. It is represented with CD. So these, now we have to follow this one. We must remember that what are the fundamental physical quantities and what are the units and what dimensional formula symbol we are using. Then only we can able to go for further topics. Then there are two supplementary physical quantities. One is the plane angle, unit is the radian. There is no dimension for that. Another one is the solid angle, that unit is the steradian, and there is no unit for that one. How to find out the measurement of the length, measurement of mass and measurement of time. These three, how to find out. There are different systems already, you know that. See, when we can go through the long distances, we can use that kilometers like that. When we can go through the small distances, you can say that centimeters like that. When we can go more small means, we can say that 10 to the power of minus 6 means micro. So like that there are different units to find out the length, even it is more. And small distances we can say angstroms also, 10 to the power of minus 10 meters. So always you should remember that when the measuring of the length, long distances mostly we are preferring the kilometer. 1 kilometer equals to 10 to the power of 3 meters. Like that 1 meter equals to 100 centimeters. And while doing the problems, you must remember that 1 centimeter equals to 10 to the power of minus 2 meters. Like that 1 centimeter equals to, we can take it, 10 to the power of minus 2 meters. Like that 1 angstrom equals to, very small, this is 10 to the power of minus 10 meters. When we are expressing in terms of centimeters, 1 angstrom equals to 10 to the power of minus 8 centimeters. Like that 1 nanometer also we can take it 10 to the power of minus 9 meters. So these are like for more distances, for small distances, like that we should measure of the length. Like mass is there. But heavy objects always we can represent like kg. That more weight we can express in terms of tons, and in terms of megaton, million tons also we are using. Look here, 1 kg equals to 10 to the power of 3 grams. Like that 1 gram equals to 10 to the power of minus 3 kgs. Like that we can 1 ton equals to 10 to the power of 3 kgs. 1 mega equals to mega or million, 10 to the power of 6. Like that 1 giga equals to 10 to the power of 9. So like that we can measure that heavy weight and small weights also we can use this one. Microgram, if they are saying microgram means 10 to the power of minus 6. milligram means 10 to the power of minus 3. So like that we can measure the mass of that one, and these are belongs to conversions. When we can go through the time, know that 1 hour equals to 60 minutes. Okay, 1 minute equals to 1 by 60 hours. Like that 1 minute equals to 60 seconds. Then 1 second equals to 1 by 60 minutes. These are the conversions. Like that 1 hour equals to how many seconds? 60 into 60, 3600 seconds. Like that 1 second, how can you write in terms of hours? 1 by 3600 hours. Like that we can convert, we can give the relation between different systems. And one more thing, while measuring the speed and velocity, you can take it 1 km/h. How to convert into meters per second? This is kilometers. 1 kilometer, how many meters? 10 to the power of 3 by hours. Meters by hours means we are taking 3600 seconds. After simplification, we are getting 5 by 18. One example, look here, that is the 360 km/h. How to convert into meters per second? 360 into 5 by 18. Whenever we are multiplying with 5 by 18, we are getting 20 into 5, 100 meters per second. Like that we can convert from km/h to meters per second. Like that when we are doing the reverse, they are giving meters per second. How to give that relation? 1 meter per second equals to 18 by 5 km/h. 18 by 5 km/h. Suppose we are taking 100 meters per second. How to convert into km/h? 100 into 5 by 18. 100 into 18 by 5. Like that we are getting 360 km/h. So anything based on that problem, we can convert CGS to MKS or MKS to CGS, and SI unit MKS till MKS only they have given 3 physical quantities fundamental, but in SI system there are 7 physical quantities. Here I want to give that few dimensional formulas. Based on the formula, how to write the dimensional formulas. You know that there are 7 fundamental physical quantities, and what is the unit and what is the dimension formula. But derived are we are getting from the fundamental physical quantities. Now I want to share with you few examples from the formula how to write the unit and dimension formula. Look here, first I am taking, first one is the area. First physical quantity is the area. Area, what is the formula? Length into breadth or length into height, like that we are taking. Anyway, length into breadth. Unit is meter into meter, meter square. Then how to write the dimension for this? Meter dimension is the L, power is how much? L square. Like that volume. Volume is the length into breadth into height. This is the formula. This is also expressed in meters into meters into meters. We are getting meter cube. We can say that L cube. Then like that we can say that mass. Otherwise velocity. Velocity, what is the formula? Velocity equals to displacement by time. Displacement is nothing but length only, meter per second. Meter is the L. When time is coming, T inverse. LT power minus 1 is the unit for dimensional formula for velocity. If you want to put m power 0 also, you can put in all these cases. But there is no difference. M power 0 is 1. So no need of writing here. Then we can go through the acceleration. Acceleration is the velocity by time. Velocity, you know that meter per second. One more time means this unit is the meter per second square. So no change in L power 1 only, but T power we are getting LT power minus 2. Like that we can go through the momentum. Momentum. So when you know the formula, momentum is the mass into velocity. Mass unit is the kg. Velocity unit is the meter per seconds. How to write this one? M L T power minus 1. Like that force. Like that force. Force, what is the formula? Mass into acceleration. Mass is the kg. Acceleration is the meter per second square. Just now we know that. So M L T power minus 2. Like that work or energy. Both are having, is it potential energy, is it kinetic energy, is it heat energy, is it electrical energy? Whenever the term either work or for energy is coming, same unit we can observe that work done, force into displacement. So force, already you know that kg meter per second square. Otherwise you can say that for it, this unit is the Newton second. But when you can R, you can say that kg meter, this is not second, meters, into meter by second square. So dimension formula, look here, m L square T power minus 2. So either work done, energy like kinetic energy, half mv square. Potential energy, mgh. Is it work done? You know that work is stored as a energy. That's why energy and work all are having the same dimension and same unit. We can say this is scientist name joules also you can express. Like that surface tension, force per unit length, that formula is surface tension S equals to F by L. Force is, you can express Newton, length is the meters, Newton per meter. Already you know that force dimension is mLT power minus 2 divided by meter means LL cancel, you are getting MT power minus 2. Like that any physical quantity, if you know the formula, based on the powers you can give the difference between one physical quantity to another physical quantity. So these are the uses of units and dimensional formulas, and more deeply we are discussing that how to solve that problems. There are three uses of units and measurements. First one is to convert from one system to the another system. Second one is to check the correctness of the given equation. Then third one is to derive the relation between different physical quantities. So these three uses are nothing but heart of this chapter. From this topic only you will get mostly problems based on like a NEET, Eamcet or mains. Look here. First one is to convert from one system to another system. One example we are taking. Suppose energy. There are two systems we are taking. One is the SI system, another one is the CGS system. And I am writing N1 times of this energy equals to N2 times of that energy in CGS system, SI system, and this is the CGS system. And I am taking, this is E1 and this is E2 we are taking. N1 I am taking 1 joule. 1 joule. E1, what is the dimension for energy? mL square T power minus 2. So I am taking M1 L1 square T1 power minus 2. This side N2 value we have to find out. N2 same. Here M2 L2 square T2 power minus 2. Now how to find out the N2 here? N2 equals to, look here, M1 by M2 into L1 by L2 whole square into T1 by T2 whole to the power of minus 2. But N2 equals to, M1 is SI system means we can express in terms of kgs. M2 is in terms of the grams. So you can write it kg by gram. And here meter by centimeter whole square. Here time is, both the systems we are expressing in terms of second only. Second will cancel. Then N2 equals to, for kg how many grams are there? 10 to the power of 3 grams by grams into, this is the 10 square centimeters. 1 meter equals to 100 centimeters. We can express 10 square centimeters by centimeters whole square. Then this one cancel, this one cancel. This is how much? 10 to the power of 3 into 10 square whole square means 10 to the power of 4. We are getting 10 to the power of 7. So N2 equals to how much? 10 to the power of 7. So here you can say that now 1 joule equals to 10 to the power of 7 ergs. Don't confuse. This is in SI system and this is in CGS system. And you can say that here 1 erg equals to 10 to the power of minus 7 joules. Like that we can convert from one system to the another system. Then our one more application we are discussing here. Suppose now we are taking the force. SI unit is the Newton and CGS unit is the dynes instead of energy. Most of the problems you should practice number of problems based on this and these three uses only. Suppose we are taking force. Dimension formula is mLT power minus 2. One side I am taking SI system, another side I am taking CGS system. So instead of N1 and F2, F1 and this is the N2, F2. N1 I am taking 1 Newton. F1 what is the dimension formula? M1 L1 T1 power minus 2. N2 instead of F2 what we are taking here? M2 L2 T to the power of minus 1. Same here N2 is how much? M1 by M2. This is in kg, this is in grams. So 10 to the power of 3 we are getting. Then L1 by L2 10 to the power of 2. Time will cancel. Finally N2 equals to 10 to the power of 5. So you can say that 1 Newton equals to 10 to the power of 5 dynes. Like that 1 dyne equals to 10 to the power of minus 5 newtons. Like that we can convert from one system to the another system. Whatever the system, like that we can find out either you know the Newton, you can find out the dyne. When you know the dyne, you can find out the Newton. Two problems are belongs to from the principle of homogeneity or to check the correctness of the given equation. Look here, the given data is what here. First one is P belongs to pressure, X belongs to displacement, T belongs to time. Here A, B, C are the constants. The question is find the dimensional formula of A by B. How to find out? Just now we know that how to split this one. P equals to A by Bx minus Ct square by Bx. From the principle of homogeneity we know that dimension of X must be equals to, which is the easiest you can check it. If you are taking this one it's lengthy, so we can go through this one. P equals to A by B is the constant by 1 by X. X is the displacement. So A by B equals to dimension of pressure is the mL power minus 1 T power minus 2. You must by heart the formulas and dimension formulas. Then only you can able to, when you are doing the cross multiplication, dimension of X is the length. After simplification we are getting the dimension of A by B is the mt power minus 2. So like that with the help of the principle of homogeneity easily we can able to find out the dimension of A by B. And one more expression they have given. This is the van der Waals equation also. P belongs to pressure, V belongs to volume. They are giving in the question. Don't worry and don't think this is the velocity in this. This is the V minus V. As usual A and B are the constant. This is the nRT. N is the number of moles, R is the universal gas constant, T belongs to temperature. Then how to solve this one? You can split this one. But the question is we can find out the AB, which is the easiest method. You can equal these two. PV, dimension of PV equals to dimension of AB by V square. After simplification, AB equals to PV cube. Instead of pressure, you write the dimensional formula of mL power minus 1 T power minus 2 into L cube whole cube is the L power 9. After simplification, you can get it. This is the dimensional formula for AB. Like that. So this is the use of the to check the correctness of the given equation. Our second application is completed. Then third one is derive the relation between different physical quantities. It is also very important. If we don't know the relation between different physical quantities, we can able to find it. See, come to one example here. Suppose in that problem they are giving time period is depending on the acceleration due to gravity and length of the pendulum. So you don't know about what is the power of that G. We are taking G power A and L power B. See, we should give the relation between these two physical quantities with the help of the third application to derive the relation between different physical quantities. See, what is the dimension of time period? T power 1, LHS side. G power, what is the dimension of acceleration due to gravity? You must by heart the dimensional formulas from the table. Nearly 80 to 90 dimensional formulas are there from intermediate. LT power minus 2 whole to the power of A. And length dimension is capital L whole to the power of B. Now you look here, we are writing t power 1 is directly proportional to L power, how much is there? L power A, t power minus 2A, then L power B. If the bases are equal, we can add the power. So L power A plus B and t power minus 2A. Look here, there is no mass term, so we can take it m power 0 and length power also 0 we are taking. See, LHS side, m power how much is there? 0, but this side no m, you can leave this one. L power how much is there? 0. So 0 equals to A plus B. Now you can get what is the relation between A and B. So A equals to minus B. Then t power 1 is there, 1 equals to minus 2A. Then A equals to how much? Minus 1 by 2. If we know the A, B equals to how much? Minus into minus plus. We are getting B equals to 1 by 2. Then substitute in this. T is directly proportional to G power minus 1 by 2 and L power 1 by 2. So T is directly proportional to under root. This is the power plus L by G. See, now you know that what is the relation between time period, length and acceleration due to gravity. So this is the third application. Like that, there are many problems. With the help of this concept you can practice it. And last concept from the day 1 topic is what are the limitations of units and measurements. See, actually when you are observing this formula, general formula is what? T equals to 2 pi into under root L by G. So with the help of units and measurements, you can find out the relation between these three physical quantities, but we can't able to find out the constants. How much constant? Actually 2 pi we can able to find out from the experiment only. We can't find out with the help of the units and measurements. Then for the logarithmic functions, exponential functions, trigonometric functions, we can't apply the units and measurements. And next one is if any physical quantity depends on more than 3 physical quantities. Look here, time period depends on the length and acceleration due to gravity. Suppose this time period depends on more than 3 physical quantities, we can't able to derive the relation between them with the help of the units and measurements. So these are the limitations of units and measurements. Then after listening this, you should practice that. In day 2 concept, we are going to discuss about errors. Thank you everyone. Please subscribe my channel.